Welcome to Beyond Golden Signals, monitoring in the age of generative AI. What makes GenAI applications fundamentally different from the traditional software we've been monitoring for decades? There are four key shifts. The first is non-deterministic behavior. The second is the variable cost structure. Third, we're facing new attack vectors. And finally, quality is subjective. Now that we've established why the traditional approaches fall short and what the new challenges are, we'll start with the fundamental building block of all monitoring, the golden signals, or LETS. We'll dive into the first of the golden signals, latency. Latency answers that fundamental question. How long does each request take? In traditional monitoring, we often look at that median latency, which tells us what the average user experiences, for example, 850 milliseconds. But we'd also look at those extremes, the P95 or P99 latencies, to catch the slower requests and identify the true outliers and bottlenecks. But for GenAI, you need to track latency at a more granular level. It's not just about the total time from the user clicking send to the response appearing. You've got to instrument the latency at multiple stages within the GenAI pipeline. For example, the time it takes your RAG retrieval to find relevant documents, or the time for the LLM call itself, and finally, that total request time. Understanding the latency breakdown is critical for optimizing and pinpointing where users are experiencing delays. In summary, for generative AI, track latency at multiple stages. LLM calls, external API calls, total request time. Now let's move on to the second golden signal, errors. Errors are fundamental. We need to know what is the error rate and what types of errors are occurring. In the world of GenAI, you need to segment your errors beyond the classic HTTP status codes. While traditional monitoring would cover things like 400 or 500 server errors, we must also now track a new category. That's LLM model errors. These are errors returned directly from the model provider, like the context length being exceeded, or the model safety filter being triggered, or the model simply being overloaded. But the takeaway here is to track error rates by endpoint, by model, and by user segment to quickly identify patterns and to prevent small issues from turning into major outages. The third signal that we traditionally monitor is traffic. Traffic simply measures how much demand is the system handling. We typically track this as requests per second, or RPS, over time, as you see in this chart. Now, the goal of traffic monitoring is to understand usage patterns. That's when your system is busy, and by how much, in order to ensure that you have the capacity to handle that load. And for GenAI applications, this is about more than just the total number of API calls. You've got to also segment your traffic analysis to be truly effective. This means monitoring request patterns not just by time, but by feature. For example, is it the internal chatbot or the external facing summarization tool? Also the user type. Are premium users or new users driving the most traffic? And finally, by model. Which specific model? Is it a big model, a small model, a more expensive or cheaper model? Is handling the majority of your volume? And by segmenting this traffic, you can optimize capacity, manage your model-specific rate limits effectively, and ultimately control your costs. The final signal is saturation. Saturation is all about answering the question, how constrained are your resources? It's generally measured by looking at the utilization of your critical infra. However, for GenAI apps, the bottlenecks have shifted. You must pay special attention to two new areas. The first one is GPU utilization. The second is API rate limits. But in the world of GenAI, your primary saturation warnings will come from watching infrastructure utilization and model serving capacity and associated API rate limits. This is nothing new, but they're new critical bottlenecks that you need to monitor in order to ensure that you can handle your increased traffic. All right, let's move to the first of our three critical new dimensions, cost monitoring. As we established, traditional LETS metrics completely miss the financial implications of GenAI. The cost structure is highly dynamic and unpredictable. That means if you don't have visibility, your spending can, and often will, spiral out of control. And in this section, we'll cover why this is a critical problem and, more importantly, the essential metrics and strategies you need to implement to track your spending and maintain a healthy budget. All right, let's look at why cost monitoring is absolutely critical, and it all boils down to the unpredictable nature of GenAI spend. We've identified 3 major ways costs can escalate without warning. The first is token creep. This happens when maybe your engineers or product managers are trying to improve quality, but they quietly increase the context window for the model. Without financial review, and because cost is directly tied to token count, this can result in a cost increase overnight. Second, we've got model drift. This is when your team, or maybe myself, somebody like me, an engineer on your team, might take a faster, cheaper model and then move into something a little bit more, but perhaps a little bit slower, under the premise of better quality. This change in model, even if the usage volume stays the same, can escalate your spending. And finally, there are uncached calls. In GenAI, the same query can hit the API repeatedly if you haven't implemented an effective caching layer. And we've seen cases where your spend is redundant because the system is paying for the exact same expense of model completion over and over again. And without granular visibility into these 3 areas, that's token creep, model drift, and uncached calls, your costs can escalate rapidly. So now we know what to track, but how do we get that granular data? The answer is a robust cost attribution strategy, which means one thing: you've got to tag everything. First, feature level tagging. That means by tagging your feature like summarization or text to speech, basically going in and adding that feature level tag will tell you which feature is costing the most. Secondly, user level tagging. So using tags like user ID or tagging by organization, it's essential for chargeback, accurate billing, and quickly identifying patterns of abusive usage before they drain your budget. Third, model level tagging. Tags like model or provider give you immediate visibility into the high leverage areas for cost optimization. You can benchmark the true expense of using one model versus another. And finally, endpoint-level tagging. Attributing cost to a region, environment, or provider helps your infra planning. You can see how regional distribution of staging versus prod can impact your total spend. By making tagging mandatory, you gain the necessary visibility to understand where your money is going, and more importantly, how to control your spend. All right, we're going to move on to our second of the 3 new dimensions: safety and security. Let's dive into the specifics of the GenAI threat landscape. We've categorized them based on their risk level, starting with the 2 that we deem critical: PII leakage and data exfiltration. Next, we have 2 attacks at the high risk level: prompt injection, which is probably the most common, and the next, which is related, is jailbreaking. Finally, there are 2 at the medium risk level. The first is denial of all. That's an attack against your budget. And the next is model attraction, and that involves sustained systematic probing of the model with queries to reverse engineer it. After identifying those threats, the next critical step is to implement the right metrics to detect and stop them. Simply put, we need to monitor for the security breaches that don't look like errors. We focus on 4 key metrics here. First, the prompt injection rate. Second, the PII detection rate. Third, the content moderation score. And finally, jailbreak attempts. We now arrive at arguably the most crucial of our 3 new critical dimensions: quality monitoring. As we've seen, Let's tells you if the service is up. Cost and safety will tell you if the service is budget compliant and secure. But ultimately, for a generative AI application, the only thing that truly matters is whether the output is good. GenAI presents a deep challenge when it comes to quality measurement. It's because quality in GenAI is inherently subjective, context-dependent, and as a result, difficult to quantify with traditional metrics. Let's look at the 4 core reasons for the difficulty. First, there's no ground truth. Second, context matters. Third, hallucinations are a major challenge. And finally, we're dealing with subjective satisfaction. That means that we've moved on from a binary world, where it either works or it doesn't, to a spectrum. Users are judging the response on how helpful, accurate, and complete it is. Now that we understand the challenge of measuring quality, let's look at the essential metrics you must implement to move beyond the simple "it works" status codes and truly measure the output of your GenAI app. We'd recommend tracking these 6 key metrics. First, the hallucination rate. Second, the relevance score. Third, user satisfaction. Fourth, we move on to answer completeness. And before last, we've got retrieval augmented generating. You must get back your retrieval quality. And finally, your response coherence. By implementing these metrics, you gain the complete multi-dimensional view of the quality necessary to optimize your app. All right, so let's bring it all together. To achieve that comprehensive GenAI observability, we've got to move on beyond the traditional golden signals. This is a complete monitoring stack that combines the fundamental Let's metrics, which tell you if the system is running, and then it integrates 3 new dimensions that tell you how it's running. The first is cost. How much are we spending? Second is safety or security. The third is quality. And by uniting these Let's metrics with cost, safety, and quality, we can gain visibility into our application's health, financial spend, security posture, as well as the quality of the output that your users are receiving. Now, of course, Datadog's been working on this problem already. We cover the standard golden signals and how they apply to your app, but we've also got cost, security, and quality monitoring that will help you monitor all of this in one central application. Datadog Large Language Model Observability. Here's a quick summary of LLM observability. We've got standard metrics that we mentioned before, so we automatically capture and visualize key metrics like latency, errors, tokens per second, and API rate limit usage directly from your LLM calls. But we also give you quality and cost. The platform allows you to track and analyze those costs associated with different models. It also helps you evaluate prompt and response quality via integrated eval tools and tracing tool usage. Safety and security. Datadog provides capabilities to monitor for security risks, including identifying and masking PII in prompts and responses and detecting potential prompt injections or unsafe content. And that brings us to the end of our session. Thank you so much for your time. To recap the journey, we started by acknowledging the golden signals. That's latency, errors, traffic, and saturation are the bedrock of monitoring. They're not going anywhere. But for GenAI apps, Let's alone leaves you blind to the things that matter most. A perfect 200 OK means nothing if your model is hallucinating, leaking PII, or burning through your budget one token at a time.